All right, we have arrived at lesson 13.5, reading scientific notation. So in this lesson, you're going to learn how to read scientific notation. And in the last lesson, you're going to learn how to write scientific notation. We're almost to the end. All right, maybe you're thinking, what does scientific notation have to do with exponents? Well, if you look at the expressions there, you can kind of see, yeah, everything is being multiplied by a power of 10 here. So a number is written in scientific notation when it is expressed as the product, so multiplication problem, of a factor and a power of 10. So a factor, that's just a number that you multiply, and a power of 10 means that in your expression it's a power, the base is 10. In order for it to be considered scientific notation, the factor, the number that you're multiplying by the power of 10, has to be at least 1 and less than 10. So it can be 1 or more, and it needs to be less than 10. You are allowed to have negative exponents when you're writing expressions using scientific notation. So in our last lesson, we learned how to simplify expressions containing negative exponents. If I ask you specifically to write something in scientific notation, those negative values are going to be kind of important. So in scientific notation, I'm not asking for simplest form. It's kind of a separate thing. And we'll talk more about that in class, but for now, just in case that was a question, in the past, lots of people have had questions about it. So right here, I have 5 and 878 thousandths times 10 to the negative 7th power. This would be considered scientific notation because here's my factor, and my factor is at least 1 because it's 5, right? And it's less than 10. I know there are a lot of digits, but that's not 5,878. It's 5.878. So this value here is less than 10. This right here, the base, is a power of 10 because my base is 10. So as long as this is a 10 here, you're good. So the very first thing I want you to do is just look at these values here and tell me whether or not it's written in scientific notation, and we're going to explain why. It's always fun to explain yourselves, isn't it? Okay, so I ask whether it's written in scientific notation. I know I'm supposed to have a factor multiplied by a power of 10. It looks like we're good in the power of 10 department. Every single one of those factors is being multiplied by a power of 10. So I think we're going to need to focus on the factor itself in making sure that it's 1 or more but less than 10. So 5.9, that's 1 or more and less than 10. And this is being multiplied by a power of 10, so we're going to say yes. In this next example, I have 9/10. 9/10 is less than 1. And the rules say it has to be at least 1. So this would be a no. And it's a no because 9/10 is less than 1. That's why. That's why it doesn't work. And this last one here, I have 11.8 times 10 to the negative 4th. 11.8, that is greater than 10. Oh my goodness. I'm sorry, it's greater than 9 actually, because it has to be less than 10. So 11.8 is not less than 10, so I'm going to say no. 11.8 is greater than 10. That's not okay. It can't even be equivalent to 10. So in order for a number to be written in scientific notation, it has to be a factor that's 1 or more but less than 10 multiplied by a power of 10. So there's a simple just yes or no. In your homework packet, all you have to do is say yes or no for that little section. It's really that easy. All right, the next part of this, I want you to be able to read scientific notation and go from scientific notation to standard form. And standard form is basically like, what is it actually worth? It's a single number, no exponents, and basically the absolute value of the exponent is going to tell you how many places to move your decimal point. So when you see expressions like these down here, I have 3 and 22/100 times 10 to the negative 4th. Instead of getting out a calculator and typing in 3.22 times 10 to the negative 4th power, because probably on this section you're not going to be able to use your calculator to do that, I want you to be able to have a good understanding of what multiplying by 10 to the negative 4th means and multiplying by positive 10 to the 5th power means. So I'm going to have a factor, and you're going to be multiplying it by a power of 10. If the exponent on the power of 10 is positive, all you have to do is move the decimal point that number of places to the right. And if the exponent attached to the power of 10 is negative, you move the decimal point that number of places to the left. So take a look. I have a 3.22 times 10 to the negative 4th power. Because I'm multiplying by a negative, that means I'm supposed to move the decimal point to the left however many places this exponent says. So the exponent's 4, that means I need to move this decimal point 4 places to the left. So I can move it 1 place, and then I see I don't have any more numbers. You're going to use zeros as little fillers, so we'll kind of just use our little U's for now. So there's 1 place, 2, 3, 4. So this is where I want my decimal point to be. And you can see that we have 3 empty spaces here. I'm going to fill those with zeros. So 3.22 times 10 to the negative 4th is equivalent to 0.000322. Feel free to put the 0 in front of it as well. I'm not a stickler about that. Either way is fine. And if you wanted to check out to see if this works, move it back 1, 2, 3, 4, and you should end up with the original number. And yes, it works. With this next one, I have 7.9 times 10 to the 5th power. This is a positive 5, and if the exponent's positive, you're supposed to move it that number of places to the right. So in 7.9, if you move it 5 places to the right, I'm going to write it down here. You should too. I'm going to go 1, and now I'm just going to make empty U's for the places where there are no numbers. So I did 1, 2, 3, 4, 5. You fill those with zeros, and technically my decimal point's at the end. So I have a 7 and a 9 and 1, 2, 3, 4 zeros. You don't have to list the decimal point when it's at the end. I would like you to list commas though. It makes it a lot easier to check. So basically with commas, you end up moving from right to left, and every 3, put a comma. So this is 790,000. And again, if you wanted to check to make sure it was right, go back those 5 places, 1, 2, 3, 4, 5, and make sure your decimal point is where it started. And it is. Right now I have 6 times 10 to the 7th power. When you just see a number without a decimal point, remember it's technically at the end. So if I was going to move this 7 places, and I'm going to move it to the right because it's a positive, I'm going to go 1, 2, 3, 4, 5, 6, 7. So that means I'm going to have 7 zeros after this 6. 1, 2, 3, 4, 5, 6, 7. Again, if you're moving from right to left, every 3 gets a comma. Voila! Alright, and last but not least, I'm multiplying by 10 to the negative 5th power. When you have a negative exponent, that means you are moving to the left. So I had 9.9. When you go left 5, because negative 5 again means left, I have 1, 2, 3, 4, 5. And I see that I have 1, 2, 3, 4 empty U's. I'm going to throw some zeros in there. The decimal point's in the front of the problem. Then I have to write it. At the end here, it doesn't make a difference, but here it sure does. So I'm going to put my decimal point, and I see I have 1, 2, 3, 4 zeros and 2 nines. I'm going to rewrite all those. Again, if you put the 0 as a placeholder in the front, I'm good with that. If not, it has the same value, so it's all good. Believe it or not, you're done. See you next time.